Hello everybody, this is RodLab video tutorial number 15. This video I'm going to talk a bit about the changes and new features in the Beta 4.4 release. Down below here I've got a link to the RodLab homepage, and I will put that in the comments of this video so you can easily follow it. And when you do, you will end up over here at the RodLab homepage, and if you scroll all the way to the bottom, you will find the link to the latest 4.4 release package. And up here a little bit above that we've got the release notes, and I've got the specific bullet points for the major changes in 4.4. First thing I've done is I've added a culm position usage to the taper translation and bending comparison, and what this will do, it'll allow you to specify what part of the culm you were building a rod from. We'll show you a bit more about that. Got some changes to the report, a couple, one for Excel compatibility, the ability to auto open reports when you generate them, and then some configurations to allow you to change the number format and precision of the numbers. I've got a global disable for culm rounding in the configs as well. That'll allow you to disable it for both the source and for the output rod, so you don't get a mismatch there. I've added some ferrule outlines to the taper plots. I'll show you what those look like. And some bug fixes for the Morgan handmill report. It was getting some incorrect stations, and also if you were using culm rounding or changing culm rounding in the bend form calculation, it wasn't actually pulling the culm round effect in when you were calculating bend form, so that's been fixed. So if I go ahead and close this up, I've got RodLab open in the back, and let's go ahead first thing and do open taper translation. I'll grab my 8013. And as always, I like to just recalculate the rod and make sure the old rod is on top of the new rod, and it is. So you'll notice first thing here, I've got an outline for the ferrule. The height does not actually follow the height of the ferrule, and after I wrote this and started looking at it, I realized that would be very helpful to help you see how the ferrule was going to fit on the taper. It doesn't work that way yet. All it's really showing you is on the left here, you've got a box that represents the female end of the ferrule that's overlapping on the bamboo. On the right, you've got the box for the male end that's overlapping the tip end of the bamboo. And in between, because this is a step down, I've got a box that would technically have no bamboo in it. And if I were to grab like a Super Z, you would see that box would be a lot smaller. That would just be my water seals. But let's go back to, let's just do this, recopy my source rod. So that isn't really so much what I wanted to show you, but that'll be there so you get an idea what part of the taper is being covered by the ferrule. What I really wanted to show you was this culm usage here. So if you look up here, I've got, this is my rod. So I've got an 8-foot rod, so from 0 to 96 inches, and the top part shows me what part of the culm it's being built from. So a 12-foot culm would have 144 inches. So this kind of shows me that here's my tip section that's being built out of nearly the top of the culm. I've got a couple inches missing to represent some overlapping of nodes and other things, and then my butt section is being built just below that. So you see I'm kind of not using like 0 to 44 inches here because I'm just kind of taking that out. We could do some examples here and show you how much it would change the taper if I were to build this rod differently. So let's go ahead and build the whole rod out of the very butt of a culm, including the tip in this case. So let's grab this and 47.8. So what this is going to do, it's going to build both the butt section and the tip section out of the very base of the culm. So when I do that, I go ahead and recalculate. You see my output taper is a little higher because the bamboo that I'm getting out of the butt has a lower modulus of elasticity, so I need a bigger cross section to get the stiffness. And what you might also notice is it really is not that much difference at all. So I'm looking at about maybe 1/1000th of an inch, or a little less than 1/1000th of an inch at a tip, and about 2/1000ths of an inch at a butt. So for that very big change in how I'm building the rod, it has very little effect. And the background of this is when I first wrote some of this stuff like 20 years ago, I had a different expression for bamboo. It wasn't quite as accurate in the butt section, so when I did this type of testing, I would get quite a bit more change because I had a lot lower MOE that I was using as my representation for the butt section of a bamboo culm. So realistically today, this isn't something I would recommend that you change this to reflect exactly how you are building your rods. If we have some different materials that we're using that are a little bit or have more variation from say butt to tip, this would be useful. This might be something we take out later in the future. We'll see if it becomes useful or not. And just to back that up, I'll show you I've got a bend form window open here, and I've got a couple different rods already built. I've got this red rod here is my bamboo, or it's a 8013. It's built entirely from a tip section, so both the butt and the tip section of the rod are built with the very tip of the culm. And then this black one here represents a rod built right from the butt, like we just did a few seconds ago, where basically both sections were built from the butt section, the very base of the culm. And you can see there's not really a lot of difference between the two. So for reference, let's add one more taper here. I'm going to do a taper to show you what it would look like if I were to cast this 5-weight rod with a 4-weight line. And when I do that, you can see there's, this represents, between blue and green represents 1 line weight. So you can see building out of the tip is very little difference, like a fraction of a line weight. Building out of the butt, drops it maybe a quarter or a fifth of a line weight. So very little difference. Not something I'm going to recommend that people measure their columns to figure out exactly how you're building. So that's not going to be too helpful. And again, it might be with some different materials that we'll come up with. So let's come back here and talk a little bit more about reports. So first thing, I'm just going to recopy this, go back to the standard. One thing I want to point out, I've got a station distance of 5, so this is fairly typical, obviously, for a Morgan hand mill or for planing. If I had planing forms that were built every 3 inches, I could do this, and then I would get my stations would be every 3 inches, my output stations. I'm just going to stick with 5. I've got one more number here, and that's my points per station. So what this allows me to do, I'll actually calculate station distance of 5, but I'll calculate 5 subpoints. So it allows me to calculate every inch. It doesn't show you the output of every inch here, but it goes into the final taper, and it'll go into the final report. I'll show you that when we're done here. But first things first, let's open up the config, and let's see, I've got checkboxes. I'm creating a planing report, a checkbox to create a Morgan hand mill report. I've got auto open report on now. I'm going to turn that off. I've got the application to open it, browser, taper and decimal. I'm going to change this to 4 decimal places and not taper and decimal. So I'm going to show you what this means. This basically puts the report back exactly the way it was before I did any of these changes. So the previous reports look like this. Let's come here. I'm going to go ahead and write it out. And you'll see when I do this, I get this little information window that tells me what reports were written, and it will pop up. Now, it didn't do this before, but it'll pop up the folder where they went into. So here are the reports I just created. I'm going to have a look at this planing report, and you see this is the way I've done my reports. Instead of doing 74 thousandths in decimal, I typically have the whole number 74 and then the .0 being the 10,000th position. So let's go ahead and delete those. And I had some requests for people that wanted me to do maybe a little more standard report. So if I come back in here, click taper in decimal thousandths, close that up. And now I had to write that report again. And now you'll see instead of being 74.0, it's 0.0740. If you don't like the 10 thousandths position, that's fine. We come back here and go back to the configuration and just make that 3 decimal places. And now again, I'll recreate my reports, and when I open up the planing report, I just get 74 instead of 74.0. One other little quick thing that somebody asked for was the ability to just auto open the report. So let's come back in here and grab my config so I can check this auto open report, and I've got it set to auto open in the browser. It's a little better, I'll explain that in a second here. So let's go ahead and open that report, and now when I run it, it'll pop up again the directory where the reports went, but it'll also open all 3 of those reports up in my browser. And again, so here's my Morgan hand mill report, here's my planing report, and then you'll notice these have 5-inch stations like you would expect. But this is my full report, and you'll notice, as I mentioned, I had a 5-inch station and 5 subpoints. So this will give me the taper in 1-inch intervals. So just a little more information. Not all that helpful if you're not doing something like maybe if you don't have a more accurate planing form, or if you're not doing this with a machine that you can have a little higher precision to your stations, but I like to have it. So that's there too with all the numbers. And one thing I like to do is, I typically, to get this open in a spreadsheet, I'll just right click on the planing report and I'll say open with and tell it my open office calculator. And when I do that, it'll take a second because it's trying to move from an HTML file to the OpenOffice file. There we go. And so this is effectively how I open it. And I made some changes again to the report to make it a little more friendly to open in a spreadsheet. There's a trick we can do, and this is kind of cheesy. If you want to force it to open up in a spreadsheet, you can come in here into the config and tell it to open in a spreadsheet. Unfortunately, there's some real difficulties with Windows in figuring out what your spreadsheet application is. I couldn't find a consistent way to do it like amongst Windows 7 and Windows 10 and Windows XP, which I know I have people running. So I do a little trick, and I just create an Excel file and try to open the Excel file, and it should pick the right form, but what it'll do is it'll come up, if you have Excel, it'll come up and tell you that there's an error because it's trying to open an Excel file from an HTML file, but it should still work. So I hope that'll be a little easier. I think it's probably better to just keep it in the HTML form and open it with Excel from a secondary window, but whatever works best for you, by all means go ahead. So I think that's the majority of really what I wanted to cover here right now. I'm thinking more about features for the future. The first thing that really comes to mind, I've had a couple of requests for this and I've expected it, is I want to do have a configuration to allow you to work in metric, so all the inch stuff will be in millimeters. There's been some talk about maybe doing some column usage type calculations that would allow you to measure your column where the nodes are and figure out the best way to build a rod from it. Not sure if that'll be useful for everybody, but it could be an interesting thing to try. So anyhow, if you have some ideas, of course, please let me know. And as always, thank you for listening.